Hi, I'm Sammy Cheung. I'm an undergraduate senior at MIT studying mechanical engineering and nanoengineering, and I'm currently working in Ji-won Kim's group developing flexible nanoelectronic sensors. So these are essentially these really lightweight sensors that you can barely even feel on your skin, but they can do a lot of different functions, like they can measure the skin strain or the hydration or temperature. And we're currently working on sensors that can measure different biosignals. So that's like EMG or ECG for better health monitoring. So like measuring your heartbeat or measuring like your muscle activation. And these sensors can provide a lot of different like patient comfort and more accurate and individualized treatments for a number of different reasons. So one of the reasons is the sensors are permeable, which means that they have like pores or perforations on them. And so sweat or other organic compounds can be released from the skin and evaporate. And the sweat normally induces some malfunction of the sensors. So that enables the sensors to be worn for longer. And the sensors can be worn for up to 7 days. And the sensors are also 40% stretchable, which means that they can conform with your skin and they won't be delaminated or something like that when you move around. And also, like topical drugs can be applied to the surface of the sensor through these pores on the sensors, and then they can permeate through the skin, and you can measure the EMG or other like health biosensors while these drugs are actively working. And the sensors also have an impedance that's 10 times lower than conventional electrodes, and that allows for higher quality data. So to someone who doesn't know a lot about the research, I would say that I'm essentially making these stickers, like temporary tattoos that you can wear on your skin, but you can barely feel on your skin. And they can measure different things, like they can measure your heartbeat or your muscles and determine whether you're healthy or not. And they can provide better data so you can get better treatment. So currently there's no way for the sensors to work wirelessly. The only way to make these sensors work is to use these copper wires. So that means you have to stay in one place and you can't move around or be monitored over several days while you're going about your daily activities. So one thing the lab is working on right now is we're working on making a flexible wireless system so that the sensor system can be contained on your skin or on your body. One future use of my research that I'm excited about is control over prosthetics. So we can use the EMG nanoelectronic sensors that we're making to people who have prosthetic arms or legs, and we can put the sensors on their appendage, and the EMG signals from the sensors can be translated into specific muscle activities on the prosthetic, and that allows for greater control over their appendages.